Today we are going to discuss argument and modulus of complex numbers. Now argument of a complex number is measured in anticlockwise direction and it is the angle between positive real axis and the complex number z x plus iota y for first and second quadrant. And first and second quadrant argument of z lies between 0 and pi. Also, argument of a complex number is measured in clockwise direction and it is the angle between positive real axis and the complex number z x plus iota y for third and fourth quadrant. And third and fourth quadrant argument of z lies between minus pi and 0. Generally, argument of z lies between minus pi and pi for all the fourth quadrants. Okay, so argument of z is greater or equal to minus pi and less equal to pi. Now let us discuss the each case one by one when it is in first quadrant. Case 1, this is your complex number z x plus iota y and it is making an angle of alpha with the positive real x-axis, and we take it generally measure the angle in anti-clockwise from 0 to pi, that is for the first and second quadrant. Okay, so this is your alpha. So in first case there is no problem. Argument of z, that is theta, will be alpha itself. Okay, and how do you find this alpha? You can find it by tan of alpha is equal to, you can say p by v, that is y upon x. Okay, so we'll discuss it later. Just go through like this. Here alpha is the acute angle made by z equal to x plus iota y with real axis. Now come to the second case when it is in second quadrant. I said for the first and second quadrant it will be measured in anti-clockwise direction angle. Okay, so this is your z position. So its acute angle is with the x-axis, it is making an angle of alpha. Okay, but argument is measured from the positive real axis to the complex number. So this is your argument of z. So this angle will be naturally pi minus alpha. So in this case, second quadrant, alpha is acute angle made by this complex number zx plus iota y with real axis, and argument of z will be, that is theta, will be pi minus alpha. Okay, I think it is clear. Now come to the third case. Third case is if it is lying between the third quadrant. So this is the position. So in this case we will measure the angle in clockwise direction. Clockwise direction. So 0, this is your minus pi, because in third quadrant the argument will lie between minus pi and 0. So how it happens? You know that argument of any complex number is between angle of made by positive real axis and to the complex number. So this is the angle. So how do you find this value? Now see the acute angle made by this z with the positive with the real axis is your minus alpha. You can see why I am taking minus alpha, because it is measured in clockwise direction. So this is your minus alpha. Now this angle, how you will find? The whole angle is minus pi. So minus pi minus alpha. So argument of z is minus pi minus of minus alpha. So minus pi plus alpha. In terms you can write minus common, pi minus alpha. So this is the position of argument of z in third quadrant. So for third quadrant we move in clockwise direction, so angle will be assigned negative value, as in third quadrant argument of z will be lying between minus pi and 0. Here minus alpha is acute angle made by z x plus iota y with real axis in clockwise direction, and argument of z, that is theta, equal to minus of pi minus alpha. Now it is clear. Now come to the case 4 when it is lying between the fourth quadrant. So fourth quadrant, you can see very simple. The angle made by positive real axis to this complex number and it is in clockwise direction, so minus alpha. So simply argument of z, that is theta, will be minus alpha. Okay, so here there is no that much of confusion. Here minus alpha is acute angle made by z, that is the complex number with real axis in clockwise direction. Again the same statement I have written over here. For fourth quadrant we move in clockwise direction, so angle will be assigned negative value, as in fourth quadrant argument of z will lie in minus pi to So finally you have the takeaway. Means how do you remember all this? Takeaway is this: find the acute angle alpha with this formula tan of mod of y upon x. Means we will ignore the sign of x and y. So positive value we will take, so we will get an acute angle alpha. And then we find the argument of z. How? In the first quadrant x and y both will be 0, or I mean sorry, greater than 0, positive. So directly alpha. In second quadrant x will be negative and y will be positive. So in that case you have to take pi minus alpha. You have to remember. How? I have already explained. Now in the third quadrant, argument of z, that is theta is equal to minus pi minus alpha within bracket. Third quadrant, x is less than 0, y is less than 0. In fourth quadrant, argument of z, that is theta will be minus alpha. Fourth quadrant, what happens? X positive, y negative. Okay. So this is the takeaway. You have to remember the formula. First quadrant alpha, second quadrant pi minus alpha, and third quadrant opposite of this minus of pi minus alpha, and fourth quadrant opposite of this directly minus alpha. Okay. Now come to the one more important point regarding complex number is modulus of z, that is mod z. It is root ner x square plus y square equal to r. You know that z is, we use at x plus iota y. So r is nothing but square root of x square plus y square, and r is nothing but is the distance of z, this point from the origin. Okay, this is your x, this is your y. Okay, so x is, we can write as x as r cos theta also, because base by hypotenuse x by r is cos theta, so x is r cos theta. Similarly, perpendicular by hypotenuse sin theta, so y upon r is sin theta, so y is r sin theta. So polar form of z, we see it, this representation as r of cos theta plus I r sin theta